Chapter 4 of Science and Hypothesis. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Alex Jacoby. Science and Hypothesis by Henri Poincaré, Chapter 4. Let us begin with a little paradox. Beings whose minds were made as ours, and with senses like ours, but without any preliminary education, might receive from a suitably chosen external world impressions which would lead them to construct a geometry other than that of Euclid, and to localize the phenomena of this external world in a non-Euclidean space, or even in a space of 4 dimensions. As for us, whose education has been made by our actual world, if we were suddenly transported into this new world, we should have no difficulty in referring phenomena to our Euclidean space. Perhaps somebody may appear on the scene some day who will devote his life to it, and be able to represent to himself the 4th dimension. Geometrical space and representative space. It is often said that the images we form of external objects are localized in space, and even that they can only be formed on this condition. It is also said that this space, which thus serves as a kind of framework ready prepared for our sensations and representations, is identical with the space of the geometers, having all the properties of that space. To all clear-headed men who think in this way, the preceding statement might well appear extraordinary, but it is as well to see if they are not the victims of some illusion which closer analysis may be able to dissipate. In the first place, what are the properties of space, properly so called? I mean of that space which is the object of geometry, and which I shall call geometrical space. The following are some of the more essential. First, it is continuous. Second, it is infinite. Third, it is of 3 dimensions. Fourth, it is homogeneous, that is to say, all its points are identical one with another. Fifth, it is isotropic. Compare this now with the framework of our representations and sensations, which I may call representative space. Visual space. First of all, let us consider a purely visual impression, due to an image formed on the back of the retina. A cursory analysis shows us this image as continuous, but as possessing only 2 dimensions, which already distinguishes purely visual from what may be called geometrical space. On the other hand, the image is enclosed within a limited framework, and there is a no less important difference. This pure visual space is not homogeneous. All the points on the retina, apart from the images which may be formed, do not play the same role. The yellow spot can in no way be regarded as identical with a point on the edge of the retina. Not only does the same object produce on it much brighter impressions, but in the whole of the limited framework the point which occupies the center will not appear identical with a point near one of the edges. Closer analysis no doubt would show us that this continuity of visual space and its 2 dimensions are but an illusion. It would make visual space even more different than before from geometrical space, but we may treat this remark as incidental. However, sight enables us to appreciate distance, and therefore to perceive a 3rd dimension. But everyone knows that this perception of the 3rd dimension reduces to a sense of the effort of accommodation which must be made, and to a sense of the convergence of the 2 eyes that must take place in order to perceive an object distinctly. These are muscular sensations quite different from the visual sensations which have given us the concept of the first 2 dimensions. The 3rd dimension will therefore not appear to us as playing the same role as the 2 others. What may be called complete visual space is not therefore an isotropic space. It has, it is true, exactly 3 dimensions, which means that elements of our visual sensations, those at least which concur in forming the concept of extension, will be completely defined if we know 3 of them, or, in mathematical language, they will be functions of 3 independent variables. But let us look at the matter a little closer. The 3rd dimension is revealed to us in 2 different ways by the effort of accommodation and by the convergence of the eyes. No doubt these 2 indications are always in harmony. There is between them a constant relation, or, in mathematical language, the 2 variables which measure these 2 muscular sensations do not appear to us as independent. Or again, to avoid an appeal to mathematical ideas which are already rather too refined, we may go back to the language of the preceding chapter and enunciate the same fact as follows. If two sensations of convergence, A and B, are indistinguishable, the two sensations of accommodation, A' and B', which accompany them respectively, will also be indistinguishable. But that is, so to speak, an experimental fact. Nothing prevents us, a priori, from assuming the contrary. And if the contrary takes place, if these two muscular sensations both vary independently, we must take into account one more independent variable, and complete visual space will appear to us as a physical continuum of 4 dimensions. And so in this there is also a fact of external experiment. Nothing prevents us from assuming that a being with a mind like ours, with the same sense organs as ourselves, may be placed in a world in which light would only reach him after being passed through refracting media of complicated form. The two indications which enable us to appreciate distances would cease to be connected by a constant relation. A being educating his senses in such a world would no doubt attribute 4 dimensions to complete visual space. Tactile and motor space. Tactile space is more complicated still than visual space, and differs even more widely from geometrical space. It is useless to repeat, for the sense of touch, my remarks on the sense of sight. But outside the data of sight and touch, there are other sensations which contribute as much and more than they do to the genesis of the concept of space. They are those which everybody knows, which accompany all our movements, and which we usually call muscular sensations. The corresponding framework constitutes what may be called motor space. Each muscle gives rise to a special sensation which may be increased or diminished, so that the aggregate of our muscular sensations will depend upon as many variables as we have muscles. From this point of view, motor space would have as many dimensions as we have muscles. I know that it is said that if the muscular sensations contribute to form the concept of space, it is because we have the sense of the direction of each movement, and that this is an integral part of the sensation. If this were so, and if a muscular sense could not be aroused unless it were accompanied by this geometrical sense of direction, geometrical space would certainly be a form imposed upon our sensitiveness. But I do not see this at all when I analyze my sensations. What I do see is that the sensations which correspond to movements in the same direction are connected in my mind by a simple association of ideas. It is to this association that what we call the sense of direction is reduced. We cannot therefore discover this sense in a single sensation. This association is extremely complex, for the contraction of the same muscle may correspond, according to the position of the limbs, to very different movements of direction. Moreover, it is evidently acquired. It is, like all associations of ideas, the result of a habit. This habit itself is the result of a very large number of experiments, and no doubt, if the education of our senses had taken place in a different medium, where we would have been subjected to different impressions, then contrary habits would have been acquired, and our muscular sensations would have been associated according to other laws. Characteristics of representative space. Thus, representative space in its triple form, visual, tactile, and motor, differs essentially from geometrical space. It is neither homogeneous nor isotropic. We cannot even say that it is of 3 dimensions. It is often said that we project into geometrical space the objects of our external perception, that we localize them. Now, has that any meaning? And if so, what is that meaning? Does it mean that we represent to ourselves external objects in geometrical space? Our representations are only the reproduction of our sensations. They cannot therefore be arranged in the same framework, that is to say, in representative space. It is also just as impossible for us to represent to ourselves external objects in geometrical space, as it is impossible for a painter to paint on a flat surface objects with their 3 dimensions. Representative space is only an image of geometrical space, an image deformed by a kind of perspective, and we can only represent to ourselves objects by making them obey the laws of this perspective. Thus we do not represent to ourselves external bodies in geometrical space, but we reason about these bodies as if they were situated in geometrical space. When it is said, on the